Okay, sorry about that, guys. I'm going to have to let this be part 2 of this video just to make sure I can cover this last problem. Okay, so anyway, it tells us that the long diagonal of a kite bisects the short diagonal so that I can say that BE is congruent to ED, and the reason for that is definition of bisector, or I can put definition of perpendicular bisector, and again, I'm going to abbreviate that. Okay, definition of perpendicular bisector. I'm cutting BD in half. Okay. All right, the next thing is it says is a perpendicular bisector. So that means that we're forming right angles there and there. All 4 of those angles right there at the intersection, they're all 90-degree angles. So I can say that angle BEA, okay, and angle DEA, okay, so angle BEA and DEA, both of those are right angles. Kind of writing small here. Both of those guys are right angles. Why is that? Same thing. Definition of perpendicular. Oops. Definition of perpendicular bisector. Okay. So if I have a box here and a box here, the hypotenuse on each triangle is congruent. One of the legs is congruent. I can now say that triangle ABE, so triangle ABE is congruent. Now I chose to go ABE, so I'm going through the double tick, through the single tick. So down here I got to go through the double tick, through the single tick. So that's going to be congruent to triangle ADE. Okay, why is that? That's because of the hypotenuse leg theorem, because of HL. Okay, and now that I've proven both of these triangles are congruent by HL, now I can prove that angle ABE is congruent to angle ADE, which is what we were asked to prove in the first place. The reason for that is because of corresponding parts of congruent triangles are congruent, CPCTC. Okay, now that's option 1. Now we have another option over here, another way that you could have done this proof. Okay, and we have the given here again. We have the given. Okay, another way is I can still say that BE is congruent to ED. I can say that again. BE congruent to ED. Okay, that's also definition of perpendicular bisector. Okay, but instead of saying that these two angles are right angles, I could put triple ticks right there, right? Ticks in the middle. So if you just kind of imagine, that we had this problem right here. If the right-hand side, okay, was gone away, then I can say that AE is congruent to itself. Okay, so I can say AC is congruent to itself because of reflexive property congruence, RPC. All right, and now I can say that the two triangles are congruent. I'll do the same thing I wrote over here. Triangle ABE is congruent to triangle ADE because of side, 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 side. And then I can do the last step again. Angle ABE is congruent to angle ADE because of CPCTC. Okay. All right, so that's it for these videos, both parts 1 and 2, and we will see you on the next one.